Welcome to myprojectbazaar.com. In our project title is Lossless Compression of JPEG Coded Photo Collections. Let's go with our project abstract. We propose a novel lossless compression method to further reduce the size of a JPEG coded correlated images without any loss of information. This method jointly removes the intra and inter-image redundancy in the feature, spatial and frequency domains. We present a hybrid disparity compensation method to better exploit both the global and local correlations among the images in the spatial domain. The redundancy between each compensated signal and the corresponding target image is adaptively reduced in the frequency domain. Experimental results demonstrate the effectiveness of the proposed lossless compression method. Now come to our flow diagram. Our flow diagram to represent the encoding and decoding process of our images. Initially we have to give the input image. After getting our input image, we have to encode that image by using an Huffman encoding. It is our encoding technique. After encoding process, we have to compress the encoded image. That is, the original image size will be reduced by using DCT quantization. The DCT means discrete cosine transform. The main advantage of compression is to reduce our size as well as memory space. After compression, we have to get and retrieve the input image. So we applied the decompression by using an inverse DCT quantization. Afterwards, we have to decode the decompressed image by using arithmetic decoding technique. Finally, we get a original image with size. It is the main theme of our flow diagram. Our source code file was run from the command window. In current folder shows that the many files, so we have to select our source code file. In our source code file stored in main.m, so we have to run the main.m. What quality of compression you have to require? So we have to some quality, for example 2. Depends upon the value, the image will be compressed. Finally, we get our results. After run our source code file, we have to check the value of our image. So in our image, to calculate the values in the workspace, the DCT and filters, the compression ratio will be shown on the workspace. The minimum and maximum value of our compression ratio and the average length also shown. The DCT and invert DCT values are shown in the workspace, so we have to easily calculate our values of our given image. Figure 1 shows that the original image of our input image. Figure 2 shows that the restored image from the DCT. The DCT means discrete cosine transform of our input image, so we have to apply the DCT of our input image. Finally, we got the image of restored image from the DCT. After getting our restored image, we have to apply the IDCT image. That means IDCT means inverse discrete cosine transform. It is the inverse discrete cosine transform of our input image. After that, we have to encode the image by using Huffman encoding. It is the encoded image of our input image. It is the geometric transformation of our encoded image. It is to vary the scale of our input image. After geometric transformation, we have to extract our features of our DCT image. It is the shift feature extraction of our geometric transformation image. After this process, we have to apply the DCT of our shift feature extraction image. It is the DCT image. Finally, we recover our original image by using IDCT, that is inverse discrete cosine transform. It means it is using to the Huffman decoding and arithmetic encoding to use the getting our original image. So again we want to run our source code file. In previously we have to give the 2, now we have to give the 1 to get our compression ratio values. Finally we get the original image. So depends upon the value, the compression ratio will be increase or reduce. Thanks to watch this video.